Now, welcome to this tutorial of about friction. Now, what is actually friction? Friction is the force that opposes the motion and work against the motion. This is the basic definition of friction that you might have learned in the early classes. In this tutorial, what I'm going to introduce you guys is to a new concept called limiting friction. So, let's consider a particle. No forces are being applied to this particle, right? So the particle will remain in rest. What will happen if a force of 2 Newton is applied to this particle? Well, will the particle move? The particle will not move. And the reason behind this is limiting friction. There is a force called friction which is opposing this applied force, and that is called friction, and the value of this friction is 2 Newton. So what does happen if we increase the force to 3 Newton? Again, the friction is opposing the motion, but this time the value of friction has increased to 3 Newton. Why is this? There is a property that the limiting friction would vary according to the applied force and would increase as this applied force is increased. I would go in this discussion later on in this tutorial. So what does happen if we apply a force of 4 Newton? This time the particle will start to move towards the right direction, right? Why is that? Always remember, there is a maximum value that limiting friction can possess. In this case, I have taken the maximum value of limiting friction as 3 Newton. F limiting is equal to 3 Newton. Always remember, limiting friction has a maximum value, and in this case it is 3 Newton. So what does happen? The particle moves towards the right position, to the right position with a net force of 1 Newton. Why is that? Because there is a force which is opposing that motion and is cancelling out the effect of this applied force of 4 Newton, and this force is named as friction. So what we have learned? We have learned that limiting friction tends to increase as we increase the applied force, as we increase the driving force or applied force. But there is a maximum value which we call F limit, beyond which the friction cannot increase, but it still works as the particle would move, therefore cancelling out the effect of this applied force. Now let me give you another concept that is called limiting, sorry for the bad handwriting, limiting that and limiting equilibrium. Okay, so let me tell you guys first of all what is equilibrium. Equilibrium is when the particle is in rest or isn't moving, or when the net forces 2 Newton to 2 Newton are equal, right? So when the net forces are 0, we say the particle is in equilibrium, that is, it is not moving. Or in another case, equilibrium also defines the position when the acceleration is 0 meter per second, right? Now what is limiting equilibrium? Well, the answer to this question can be understood from this scenario. This position is the case of limiting equilibrium. What do you guys understand? Pause the video and think. Well, if you guys had a try, let me explain you what is called, what is actually limiting equilibrium. Limiting equilibrium is when the applied force, that is AF, is equal to F limit. This is limiting equilibrium. That is when the applied force is equal to limiting friction. Mean the particle is just about to move but hasn't moved. The particle is about to move but hasn't moved. That is, it is in limiting equilibrium. That is, it is on the verge of the movement but hasn't actually changed its movement. Always remember what is limiting equilibrium. Limiting equilibrium is when the applied force is equal to limiting friction. So there are two things to understand. First of all, in limiting equilibrium, the particle is on the verge of movement, and in limiting equilibrium, the value of limiting friction is at its maximum. Now, I'm going to give you a formula. Let me erase this. So what we have understand? We have understand what is limiting friction, what is limiting equilibrium. Now we need to understand a formula to solve questions. What is the formula of limiting friction? And that is F is equal to mu R. F is equal to mu R. This is equal to limiting friction. Let me break out the components of this formula. So, mu, what is this mu and what is this R? Remember, these two things are being multiplied to calculate the limiting friction that an object possesses. So what is mu? Mu is actually a Greek letter, and it is a constant Mu is a Greek letter and it is a constant, and it has a value between 0 and 1, but always remember, in some cases mu can be greater than 1. The value of mu is between 0 and 1, but it can also be greater than 1. Now another thing to understand, how does the value of mu varies? The value of mu depends on the surface. If the surface is more rough, then the value of mu would be greater. For example, if this surface is rough and we place a particle, then perhaps the value of mu might be 1.2. But if a surface is less rough, mean it's more smooth compared to the previous surface, then the mu value would be less, and that would be, for example, 0.8. But always remember, if we have a smooth surface, then the value of mu would be 0. This means that there would be no value of mu. What I have told you guys, the value of mu is a constant The value of mu could be between 0 and 1, but it could also be greater than 1. The more rough the surface, the greater the value of mu. There is a direct relationship between the roughness of the surface and the value of mu. So, and when the surface would be smooth, the value of mu would be 0. So, now what is R? What is R? R is a symbol of normal contact force. I will not go into detail of telling you guys what is normal contact force, as I will explain this concept in another video. But the basic idea behind in telling you guys in this tutorial is that normal contact force is a type of force which would be given in the question, and when you will multiply it with the mu, we will calculate limiting friction. But when the value of mu would be 0, as in case of smooth surfaces, and if we multiply it with the normal contact force, then the answer of friction would be 0. So we can conclude that in cases of smooth surfaces, there is no friction because the value of mu is 0. As I've already told you guys that I will not go into detail telling you what is this normal contact force, as I will explain this in another video. But in this tutorial, the basic thing that you guys need to understand that this force might be given the question, and the only thing you need to do is multiply it with the mu, and you will calculate limiting friction. The last thing that I would like to tell you guys that there are two basic things, that is F can be equal to mu R, and then we would be in limiting equilibrium position. But if F is less than mu R, then the object is not in limiting equilibrium and the object would not move. So I hope you guys understand what is meant by limiting friction, what is meant by limiting equilibrium, how to calculate limiting friction, what is the formula of limiting friction, and this is the end of today's tutorial. Thanks. Don't forget to subscribe to my channel and support my work.